Hey everybody, this is Larry. This is me going with Q4 of the bi-weekly contest 150, shortest matching substring. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this one. So this one, well, it is just easier than Q3, if you ask me. Or at least like it's easier to reason it out. I actually still end up taking a while, and honestly, because I didn't solve Q3 because and I took a long time on Q3 before skipping to Q4, so but it's actually not that bad. During the contest, I'm not gonna lie, I had like 20 minutes left or something, so I was just trying random YOLO things in the beginning, including I was wondering whether regex can give me the shortest answer, but the answer was I couldn't figure it out how to do it, which kind of wasted some time, ironically. But yeah, the key part is noting that the constraint where there are exactly 2 star characters, and after you kind of come into terms of that, then all you have to think about is that the way that I thought about it is in terms of like item hopping, if you will, right? So basically, if you start at for example, you look at this example, you go to BA, you start here, and then you can just hop to the next C and then the next CE, right? And that's really the core idea is this, okay. And the thing about this problem is that there's a greedy component, right? Because basically, okay, let's say you start at this BA, well, it never makes sense to choose a later C, right? That's just the way it is. I mean, because, and you can make some, like we can do exchange argument, whatever, but I'm not going to prove this. It's too straightforward to see, right? Because if you choose a later C, then you can only give your worst result. So, and you can actually use that with the dirt piece as well. So that's it, right? That means that if you start here, then you always want to greedy choose the next C, and then greedy choose the next CE, and then you're done. Okay, so what is the harder part about this one, right? Is that, well, and because we only have 2 star characters, we only have to do this twice. There are a couple of ways to think about it, but I think I did it with binary search, but I think you can add. But you could actually use it with like almost like a sweep line kind of thing. But we'll talk about that. We'll upsolve this later, perhaps. But yeah. But the key thing to know is that here, then now you have to use a string finding, a needle in a haystack algorithm, right? A string matching problem, which is that, you know, of entering. Okay, if we have BA, find all instances of BA. If we have a C, find all instances of C, and we have CE, we have find all instances of CE. There are a couple of algorithms here. There's Robin Carb, which was my first idea, and I was like, oh wait, we could use the Z algorithm, which has a lower overhead, I think. You can also use KMP. There are a lot of string matching problems that gives you order. As long as you use one that gives you order index, you're fine. I honestly have this code pre-written somewhere. So I use Z algorithm. I don't even remember anything about this. So you know, it is what it is. I just kind of copy and paste it and use it as a black box, right? And here, then now, yeah, we might as well go over the code, which is that we split the star into basically the left, the center, the right. It is what it sounds like. And then we calculate the left, the center, and the right, keeping in mind that this gives us all the indexes, at least the way that I set it up, gives me all the indexes of where it matches. And I added an extra thing at 0, or if there are no characters in between 2 stars or the last character, then it is length 0, and then we just enter one there so that we could kind of match it. But that's basically the idea, is that okay, left will have all the index, C will have all the index for the middle one, and then the right. And then now all we have to do is brute force the first starting character. So this is saying that okay, if the first starting character is I, then we binary search I plus the number of characters on the left side. We binary search for this one. We have some if statements to make sure that we don't go out of bounds. But otherwise, then now we binary search on the center piece to get the right one. And the binary search, as we said, is going to be greedy. It's going to give you this first index that matches. So we're always going to be good. And yeah, and that's pretty much it. And I had the C1, C2, C3 for debugging, but yeah. But the left side, remember, the first character is I, and then the last character is going to be this current plus the last thing. And so this is the right side, this is the left side. We subtract them to get the width, and that's it. And then we just choose the best of all the starting indexes. And if we cannot match, we return -1. Otherwise, this is good, and that's it. Right? What's the complexity here? Well, Z algorithm is going to be O of n, maybe n plus m if you want to call it that way, right? The split is O of m. Let's just say m is p. Like write it out, even though I don't use it, right? This is O of n plus p, or n plus m. This is O of n plus m. This is O of n plus m, right? You could use it as a black box. I did anyway. Yeah, and then for each loop, we binary search, we're done, right? So that's basically it. And yeah, so this will be n log n, and we'll be happy. What is the running time of this, actually? I'm curious. So this actually took 3 seconds, not too bad. But I think one thing I noticed as I was explaining this now is that we can upsolve it. So if you really, this is my Z algorithm. If that's all you care about, Z algorithm and binary search. This is to calculate all the indexes. So actually, I could go over this a little bit more, which is that the Z algorithm actually gives you the longest prefix it matches. So the way we set it up, if the prefix matches this the string, then that is an index, and that's how we calculate all the indexes. And then we have binary search. But keeping in mind that this binary search, we could use the 2 pointers algorithm, right? We have to use it twice, so I guess maybe it's the 3 pointers algorithm, but that's the idea. Yeah, and here maybe we can just use yeah, like we can do right. And this is now me upsolving it using a deck. I guess I could just put it here. Maybe that would have been better. What? Why did I write it like that? I think I confused myself. There was no Q. Okay, fine. Oh, this. Yeah, I don't know why I wrote it this way. This is very weird. Some kind of nutty thing going on. Okay, so then now this gives us text. So then now, yeah, we can say I is equal to q.pop left, right? Which would be. Is that right? I think this is right. I was just thinking about a case where the first thing is a empty string, but I think this is right? And this is L dot pop, not just Q, right? So then now we have the current, right? And instead of binary search, we can say, yeah, if length of C is greater than or is equal to 0, then we continue, right? I guess we could have done it even before we binary search, but it's fine. I'm not that worried about it. And then now, yeah, we want to pop while length of C is greater than 0, and current is greater than C of 0, then we just see that pop left. I think here maybe is a better place for it. Oops. Right? And then we can say current is equal to plus length of center. Right? And then now this is the same thing, which is that while length of the right is greater than 0 and current is greater than all of 0. It may be off by 1, but I think this is rosy, right? Right. And then now current is equal to r sub 0 plus length of right, and then now we can just write current minus I. Though maybe we should call it start now, just something like that. It's either that or this is off by 1, but I think this is the idea is right. I renamed something and didn't rename. Looks okay. Let's give it a submit. Is it faster? Okay, so it didn't turn out to be that much faster, which is not super surprisingly, frankly, because binary search is very fast anyway. But if you want to talk about complexity, then clearly, yeah, I didn't talk about complexity before, did I? Huh? Let me bring up the old solution real quick then. Yeah. So yeah, so before the change, you know, this loop, well, this matches at most O of n indexes, right? So for each loop, this O of n loop, there's 2 binary search and log n, pretty straightforward. Here, again, this is O of n loop. They're all while loops, but they're all amortized, right? All of these can have at most O of n items. So all of these are O of 1. So this is O of n. So this is even better. Yeah, and that's it. That's all I have with this one. Let me know what you think. Let me show you my Z algorithm. I think I probably copied it off ChatGPT or it's close to it at some point in the past. This is how I use it to match all the indexes in which it overlaps. This is just the 3 things. And then, yeah, and this is the 3-pointer algorithm, if you will. And that's it. Linear time, linear space, and yeah, thanks for watching. Yeah, stay good, stay healthy. Oh wait, no, not that. You can watch me solve it live during a contest next. Alright, I have to come back to this. Let's see. Shortest match substring. Exactly 2 stars. So exactly 2 things. I should write ahead first. I don't know. My brain's not here today. Star. Okay, so 2 stars. What does that mean? That means that, okay, so here we have B. The earliest B is with mine is still in the first form, that's why. Maybe, I don't know. We only have 3 cases, right? 0 stars, 1 star, and 2 star. Then it's the latest. Okay, so we're going. Okay, so then now the only 3 cases probably states, right, is the latest where you can finish here. Or is it 3 states? I can't think today. I'm stuck on my head's still in cute where I can't focus. I wonder if regex works. I'm just gonna YOLO regex. Because I forget what it is. I guess it could be dot. That's right. Would it match the shortest though? I don't know actually. Today is just not my day. That's fine. I thought it would at least do something though. I didn't think it would oh, not match, find or. It's not a find or. Oh, this is good. This is not as good. Why doesn't it though? Or is it the other way, I think, actually? Oh, but this matches more. My brain is not today. Does this help? Oops. No, it still catches the Okay, so we shouldn't do it this way anyway, but I was just wondering. Okay. Okay, how would you do it with 1 star? 1 star would just be substring, substring, right? So then it is just the previous looking at thing. Okay. Yes, I got it. Exactly 2, so there's actually always 2. I don't know that I could do it in time though, but that's fine. I'm trying to think how to do it without warp and crop. Maybe it is what it is. What's it called? Not warp and crop, the other one. C string. Nope, this is S plus. Nope. Oh man, that's why I got confused. I always forget how it goes actually. I just put it out. After 12 minutes, maybe I should be able to do it, but okay, so BA is so is it the other way? It is the other way then. I always forget which way it is. And then it starts at is this way? Oh yeah, because it cuts off the first 3, so then it is at here. Okay. I'm gonna keep it up for now. So this is just n if minutes, don't rush it. 1 and 5, 1 and 5, okay, 4, 8, 11, 4, 8, probably right, 8 and 11 for CE, okay, okay. So then now with these two things, we have do we always want to be greedy? And get the next instance? I guess so, right? I should be able to solve this, but I'm just annoyed. Okay, so then now, yeah, so we start at here. Whatever, naming is terrible, but okay, so then now we bisect. This is the index. Right, so the index is oh wait, no, it's I plus the length of the thing. Current, and now is a new index, which is C of C of index, and else we continue, otherwise we do it again, but for right. And then the length is just current plus length of R. I guess I is start. Oh yeah, I knew that, of course. I would have submitted it though. I forgot because I was just so distracted. That's not right. Why is it not right? 0, it goes to 1. Okay. And then 1, it goes to 6, right? Five minutes left. I've messed up this one. 0 goes to 10. Why? intermediate, right? 0. Oh, wait, no. This is a disaster. CS1, right? Oh no, it's not length of C, it's length of center. And this is length of right. Larry! Okay, got those right, but these are wrong. Is really wrong. Oh, whoops. It may be wrong, but I have 3 minutes left. I needed to YOLO it. Output -1, expected 2, y. So we gotta not print that. 15. Oh. Because it's empty, because it's empty, because it's empty. I know. Yeah. I don't know if this is quite right, but whatever. I mean, it definitely is a hack, but we have 2 minutes. I'm not going to think about it. Okay. Yeah, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem and this contest and this explanation, everything in between. Yeah, stay good, stay healthy, to good mental health. I'll see you all later and take care. Bye-bye.